here is your Unit 6 quiz review. So the first one is area. I can tell already it's going to be a dy problem. This is my big clue that this is going to be a sideways graph. If you can graph it without making a table, that's totally fine. This isn't required, but I'm going to just make a table. We're going to plug in for y and get x. It's going to end up being a sideways parabola. 0 is always a good place to start. If I plug in 0 for y, I'm going to get 1 for x. I'm going to skip to 2 because I have that fraction there and I don't want to have to plot something that's going to be something and a half. And I'm also going to do plus and minus because when I square that, it's going to turn positive either way. So 2 squared is 4, half of that is 2, except it's negative. So negative 2 plus 1 is negative 1. And then I'm just going to go a little bit further, again, picking an even number so I don't have to deal with this fraction. 4 squared is 16, half of that's 8, but it's negative. So negative 8 plus 1 is negative 7. So plotting those, we get 1, 0, negative 1, 2, and negative 2, and then negative 7, 4, and negative 4. I'm going to have to turn my paper to draw this. All right, and then our other graph, y equals x plus 3. We're going to start at 3. It has a slope of 1. And so the area that we're finding is this right here. So if you want to bold your intersection points, sometimes that helps. Also, first thing we're going to have to do is make this be x equals. So if we get x by itself, we're simply going to subtract over that 3. Also, I've found that circling these helps, reminds you what you're going to put in your integral. Also, putting right and left. The right graph is the curve and the left graph is the linear one. So now we're ready to set up our integral. I want to use y values. So this is going to go from negative 4 to positive 2. And again, right minus left. So that's going to be this one, negative 1/2 y squared plus 1 minus this one. Now you have to subtract the whole thing. So it's going to be minus y plus 3, just distributing the negative through that. I'm going to combine like terms. 1 plus 3 is going to give us 4. And I'm going to just erase to do that so that I don't have to copy the entire problem all over again. So these boundaries should be y values. Everything in here should say y, and then it should say dy at the end. If you ever look down and have a mixture of x's and y's, then you have a mistake. So antiderivative, this would be 1/3 y cubed, but there's already a negative 1/2 there. So 1/2 times 1/3 is going to be a 1/6. And then we'll have minus 1/2 y squared plus 4y. The common mistake is people put x there. Again, if you ever look down and you have a combination of x's and y's, then you have a mistake. Now, you don't have to simplify this because it's free response. So we're going to do upper minus lower and then leave it alone. Technically, you would be within your rights to write negative 1/6 parenthesis 2 cubed. I'm going to simplify a little bit so I don't have to write all of that, but it's down to personal preference and what you want to put. 2 cubed is 8. So I'm going to put negative 8/6. 2 squared is 4. Half of that is 2. And then 4 times 2 is 8. I just do a little bit of simplifying because it's less writing. So that's just my personal preference. Negative 4 cubed would be negative 64. So the negatives are going to cancel. All right, negative 4 squared is 16. Half of that is 8. And then 4 times negative 4 is negative 16. And again, you can just go ahead and leave it like that. All right, this is a volume. It's going to be 3-dimensional. We want a solid whose base is bounded by these graphs. So let's go ahead and graph this. This is a parabola moved down 2. So I'm going to have 0, 2. If I plug in 1, I'm going to get negative 1. And if I plug in 2, I'm going to get 2. And you get the symmetric points as well since it's quadratic. All right, and then the other one, y equals negative x. We're going to start at the origin, have a slope of negative 1. So it's going to look like this. So this area is the base of our 3-dimensional solid. So you have to imagine, you have to use your imagination. We're going to imagine rectangles popping up out of the paper towards us, perpendicular to the x-axis. So think like a loaf of bread. You have all these slices. These are the bases of them popping up out of the paper towards you. So it's going to be upper graph minus lower graph because this is right side up. We're going to draw our rectangle. So the base of it is going to be the line, which is negative x, minus the parabola, which is this one. So we're going to have to distribute the negatives through there. So minus x squared plus 2. And then it says the height is 4 times the base. So you have this as the base, and then your height is 4 times that. And then we're ready to set up our integral. If you want to bold your intersection points, that helps. We want them to be x values. So we are going to go from -2 to +1. And inside of here, you put the area of your shape. So a rectangle is base times height. The easiest way to write that is to just put the 4 and then put all of this stuff inside squared. I guess you could write it twice if you want to. I feel like writing it more leaves more room for a copy error. Now this one I'm going to let you put in the calculator. When you put it in the calculator, you'll need an extra set of parentheses there. So I'm going to share my screen and we'll go type this in. All right, so -2 to 1. All right, we want that to be squared and then end that other parenthesis and then dx, so 32.4. All right, and then last one is our arc length. I'm going to set it up first. We want to go from 0 to 2, big square root, and underneath of that, you want it to be 1 plus the derivative squared. So just set the whole thing up blank first, and then we need to find the derivative of this function. So we're going to bring the 3/2 down. And when you do 6 times 3/2, 6 times 3 is 18, divided by 2 is 9. And then if you subtract 1 from the power, you're going to get 1/2, which means that that is 9 square root of x plus 1. So when you go to do your next step, again, I'm not doing the antiderivative yet, so I'm leaving my integral symbol, I'm leaving my dx, I'm leaving my square root. We're going to square all of this. So 9 squared is 81. I'm going to just do like a margin problem here. And the square root and the squared are going to cancel out, and you're going to get this. We're going to distribute the 81 through that, so it'll be 81x plus 81. And then I am going to just go ahead and write it all over again. It'll be 81x plus 82. You just combine your like terms together. So when you do your antiderivative, you want to think of this as to the 1/2 power. Let me go ahead and just write it that way. So we're going to add 1 to the power. So it'll be 3/2. In front of that, we're going to put a 2/3. And then you also need a 1 over 81 to cancel this out. It's a u substitution, but I recommend not writing out u equals du equals and then doing the adjustment. It just takes a long time, and you can just very simply put the reciprocal out front, and then you're good. All right, 0 to 2. We're going to do upper minus lower. Be really careful here because plugging in 0 is not going to make this whole thing 0. Sometimes that happens and that's convenient. That's not going to happen here, so just be careful. Again, you'd be within your rights to leave it like this. I'm going to simplify it just so I can do less writing. 1 times 2 is 2. 81 times 3 is 243. All right, and we're going to plug in 2 to this. And then if you plug in 0, you're going to have 2 over 243. And it's going to be 0 plus 82 to the power of 3/2. And then whatever that is, you can just leave that alone. Don't even type that in the calculator. Just leave it like that. It'll be easier for me to grade if you just leave it alone. We need to just practice keeping our hands off. And that, again, represents the distance of the curve from 0 to 2. So you're finding the length of the curve.